joining us for Teledyne ISCO's March webinar focusing on optimizing pump performance. Today's webinar is being led by Nick Daddabbo, Teledyne ISCO's Pumps Product Line Manager. If you have any questions or comments during the webinar, please utilize the chat function within Zoom and we will answer all questions at the end. And now I will turn it over to Nick.
Good morning, everybody, or good afternoon, or even good evening for our folks. It might be joining us from the Asian continent. First off, thank you for joining us today for this webinar, and I will quickly go through this. We're going to talk about optimizing pump performance, but when you think about optimizing, it's more kind of a cross between considering what you're supposed to be using, how you're going to use it, all the factors that come into play, and also maybe a little bit of troubleshooting. So that's kind of where we're going to focus today. So with that, why don't we just get started? So just a brief introduction. I am the Pumps Product Line Manager for us. Been in Product Line Manager for about 18 years, over a little 18 years. Very heavily in the pumps world with Xylem, Gould, Idex, SPX. Focused on the oil and gas, pharmaceuticals, chemical, and food and beverage markets. So a lot on the production side and scale up, and now focusing on R&D and the rest of it. So with that, let's get started. So let's quickly talk about what pumps really are. Okay, so pumps themselves is a broad term. There are two major types when you look at the pumps world. You have centrifugal pumps, which are rotating devices with impellers that increases the pressure within the containment of the pump. And then you have positive displacement that moves the mechanism back and forth, or many different ways to actually pump, opening a valve, closing a valve. And you can see to the right the many different types of pumps that are out there: diaphragm, peristaltic, piston, plunger, screw, vane, lobe, external gear, internal gear. And in that other section is actually considered syringe pumps. So and we all know that's a big world too. So when you think of pumps themselves is a very broad term. We're going to today look at the pumps, primarily what we offer here at Teledyne ISCO. That would be more the syringe pumps and the reciprocating pumps. Just a quick definition, like I said before, you have a wide range of applications across many industries: pumping material, pumping slurry, pumping food, all kinds of different types of things. Two major classifications, like I had said: the positive displacement, which physically draws fluid into the pump and then forces it out of the pump itself. So it's pull in, push out, pull in, push out. Or rotodynamic is just kind of creating a vacuum on the inlet side of the pump and sending the fluid out at a higher pressure. Okay, so we're going to focus on positive displacement today. So let's look at when you're trying to set up your pump. The one way to optimize it is installing it correctly. And some things you need to consider when you're installing it, or when you're looking at the installation, designing an installation, is what type of process is it going into? Is it in the three categories: lab, scale, pilot, or is it production? Which one of those three boxes fit? How much physical room do you need? In today's applications, it's not always just the pump. Sometimes you need to add a mixer to keep fluids in suspension, or you need to add a cooling jacket, or an external bath, or you need to add a pressure pot, or something else that would be surrounded the pump to help the fluid or material you're pumping maintain in the state you're looking for. So you really want to look at not just the room for the pump, but what else you might possibly need to keep the fluid in the state, or the material in the state that you're trying to use it in. Is it a hazardous area? I mean, obviously, that's a very, very serious thing to be considering. Some pumps today, they have arcing and sparking mechanisms inside them with just a simple gear mechanism. There's a risk for arcing and sparking. One little spark can be very bad. So you have to consider that when you're looking at the type of pump, the size of the pump, and where you're placing it, and optimizing its distance from where the application actually is going to be working. And it just goes to the next comment. Is there a long distance to cover from the pump to the controller? How are you going to control the pump? It's not just optimizing the pump performance, but optimizing the space and how it's used. So making it easier to use from a distance, maybe if there's a whole table full of controllers, is there one controller? Is there one software system to control it? You want to consider that and look at that. You know, optimizing a pump, optimizing also requires kind of an understanding of what type of effects that physical and mechanical effects have on flow performance. You know, there's mechanical variations, there's importance of displacement resolution. You know, port and tubing sizes can affect refilling or actually even filling. If you have a viscous material, you're going to want a larger inlet area or a larger outlet area. So these, you know, this is also optimizing part of the performance, right? More installation questions or more installation considerations, and considering the fluid. What is the material? I say fluid here, but you know, it could be a different type of material that you're pumping. Is it aggressive? Is it corrosive? You know, there's considerations you have to look at when you're trying to optimize your setup, using the correct material for the pump itself, whether it be a Hastelloy or maybe a titanium or something different. You want to make sure that if the fluid you're using is aggressive or corrosive, it doesn't cause any leakage or any seeping of from the metal into the material and thereby contaminating your sample. Does the fluid need to be heated? You know, heating and cooling can affect the flow rate of viscous materials, especially, and other types of chemicals that are out there. So when you're looking at installing the pump, you want to make sure that if you need to have the material heated to a certain rate, one, go back to what we said earlier about space and location where you're putting the pump, but also, do you need to have a cooling bath or a heated temperature jacket to kind of put the fluid in a state that you need it? That way it moves and flows through the system at an optimal rate, not just into the pump, but through the valves and through the piping, okay? Are there particulates in that material? I mean, when you're talking about materials like biomass that have particulates or some types of pieces in them, you know, that can clog up the work mechanism of the internals of a pump, whether it be a syringe pump or a reciprocating pump, etc. Especially if there's check valves involved. I mean, check valves get stuck a lot from viscous materials or sticky materials. So if you do have materials or particulates in your material, you want to look at, what do I have to do to make sure it continues to flow through the pump at an optimal rate and goes in and out the flow rate I'm looking for? Yeah, in some cases you'd use a mixer on the pump itself, or you can heat it up, or you can stir it in a little bit of a tank before it gets into the pump and then pumps it out. Keep that in mind. And then obviously we talked about viscosity, right? So viscosity is a big deal. I mean, molasses is pretty hard to pump because it's very thick. So is tar and things of that sort. But if you heat those up to a certain temperature rate, they become less viscous and easier to move through a system. So you want to look at the application you're trying to design, or where you're trying to, what you're trying to do with the material that you're pumping, so you can keep it in the state that you want it to, along with helping it flow through the system properly and quickly at the flow rates you designed it to. If you want it to flow 100 milliliters a minute and it's a very viscous fluid, that's a different type of pump or different type of a setup you'll have to use. Versus if you heat it up and it becomes less viscous, it can flow at 100 milliliters a minute with less effort. So you would adjust how the pump reacts. So you adjust your stroke rate, you would adjust your pressure rate. So keep these in mind. And this, as we talk about here, and just showing here, optimizing requires understanding of the fluid properties and flow performance, pressure variations too, and temperature variations, and it affects on refilling, viscosity and cavitation. So let's talk a little bit about the pumping technology. So a positive displacement syringe pump can be considered a positive displacement piston pump. That's easy to say. You can see some of the diagram there. Piston speed is controlled separately for fluid delivery and refill. With a controller, you can adjust this piston movement and the stroke rate, etc. Refill obviously gets slowed down for viscous fluids because you're going to have, you want it at a certain rate. So the type of material you're going to use will affect the flow rate that you're trying to get out of the pump. Just looking real quickly, there's this picture about the design at the top of the syringe pump. You can see the cylinder cap steel. It's kind of a static piece, doesn't necessarily move. The piston seal moves, and you can see the cylinder and the piston there. As we get into, this is a bit of a chart about the syringe pump that Teledyne ISCO offers, but just to give you, just to look at it real quick, you can see the variance of flow rates all the way up to 408 milliliters a minute. And the pressure rates are 30,000 psi. So you obviously can see with a bit of an accuracy variation from 0.3 to 0.5. Those are just the standard pumps. There are options, as we talked about earlier, that you can add on to certain pumps to get it down to 0.1. And you look at the models, obviously the lower pressure to higher flow rate, higher pressure, lower flow rate capabilities. And just to give you a bit of a schooling, the numeric number where it says 1000D, 500D, that is actually the size of the cylinder. So keep that in mind. So special considerations, and these, I wanted to say that when I showed an example of these special considerations, we are focusing in on the solutions that Teledyne ISCO offers. So there's obviously other pumps out there, there are other syringe pumps, but these considerations, the way they're talked about, are solutions that are created, that are solved with the Teledyne ISCO product. And continuous flow. This is really easy. I mean, optimizing pump performance. So let's talk about this in the standpoint of that. You know, if you're looking for a continuous flow, continuously moving fluid through the system or through your application, you have a couple ways to do it when you look at our products. You have multiple systems here where you can do two syringe pumps with a valve package, and there's different types of valve packages out there. Or you can use a one pump of our reciprocating pump line, the Reaxis, that has a single or it has a dual head. So it works in the same manner, but it gives you a smaller footprint for that. There's obviously trade-offs between the two types of products, two types of pumps. But if you need continuously flowing material, typically you're either going to want two pumps working in synchronization, or you're going to want a pump that has two heads that are in synchronization. Okay, so that's the simple solution there. That's not really a problem, but it's a concern or a question. You can also use two different pumps if you so chose, but probably in most cases the more cost-effective path is to go to one or the two that we just spoke about. Earlier we talked about viscosity. You can heat a fluid to change its viscosity. You can cool a fluid that changes viscosity. The pumps, we have actually a special set of pumps that has a larger port. If you recall earlier, I was talking about you might need port changes or larger ports to move fluid. We have a version that actually has that capability, and it can come in single or dual versions like our previous conversation if you need continuous flow or if you need singular flow. And you can pump anywhere up to 300 centipoise from motor oil, which is still kind of thick in and of itself, or 10,000 centipoise, which is some molasses level, kind of a sticky level. But it's a larger port, they're 3/8 inch, and there's heating jackets that you can use, or heating packages you can get that will also change the temperature of the fluid. And you can also heat the fluids externally in an external bath to make the fluid a little warmer or less thick and before it gets into the pump. So there's a lot of options there if the material you're trying to move has a high viscosity level. That will, because viscosity level, obviously we said earlier, does affect the performance of a pump. Okay. Corrosive materials, that's something we did address earlier. You can look at different types of pump construction, whether it be a singular pump or a dual pump. And you want to make sure that when you're looking at that, if you have concerns about how corrosive or aggressive the material is, that all of the flow path is considered to be chemically compatible. When I say chemically compatible, you can reference a corrosion chart that are available online all over the place to make sure that the material that's in your seal, in the valves, and all your wetted parts are all chemically compatible so that they do not leach into the fluid, the metal does not leach into the fluids, or worse yet, erode at the metal or material you're using on your fluid path and cause a leak. Those are extreme things you need to be aware of. So that's something to think about. And from an optimization standpoint, I also look at optimization from the standpoint of it being long lasting. And if you're using an aggressive chemical, you're risking a leak happening, but you're also degrading the life of the performance of the pump. You're making an investment. You kind of want to have the pump last a significant amount of time. We discussed earlier about keeping things in suspension. If there's certain parts and pieces or bits and pieces of material within the material you're moving, one solution is to install a mixer. Now you can mix it in a tank out external to the pump before it gets pumped into the system, or you can do it right in the cylinder. With our case here, we have an option where you can actually install a mixer that goes down into the cylinder of the syringe pump and keeps the fluids moving as the piston is pumping things out. So two things are happening at once. Currently, it's an air motor, and there's in the short-term future here, there's an electric motor coming. So keep in mind when you're looking at a mixer like this, there may be some noise level because you have an air motor that is driving it. But this is a perfect case that if you have particulates in your fluid, or you need to keep the fluid stirring so it doesn't settle and stick at the bottom of the pump and cause pumping issues, which go again back to optimization. You're keeping the thick, sticky fluid moving, or a fluid that has particulates and keeping it moving so it doesn't sit at the bottom or settle at the bottom of the pump is a way to optimize to ensure that you're going to get the best pump performance with that material. This is one method to do that. Okay. As we head into the home stretch here, there's some troubleshooting things to think about here that you're looking at once you set up your pump. So one of the things you may see, if you see bubbles in the outlet of the pump itself, the material coming out, a couple things to think about that could be happening, and you should look at and consider taking a look at these things. So if maybe the air is not purged correctly, you want to retighten all your fittings. Make sure the inlet line has fluid. Do a pressure leak check the inlet line, just to rule out any issues there. If the inlet line leaks, pump the initial flow to waste and pre-pressurize it, then flow back to waste. So it kind of just tests out to make sure that there's no leaks or that the leak may show up. If you notice there might be cavitation, something to do there is lower the viscosity a little bit, increase the temperature to make it a little thicker, so it stays in the system, it stays complete into the system. You could also increase your reservoir pressure using a pressure pot and some gravity. Okay. Next potential symptom is you have a variation in your flow. So you might have, so if you have room temperature changes, you have to worry about. You could either put an insulating cover on there or a temperature control jacket to maintain. You want to keep the pressure constant as much as you possibly can. So if your room is hot, cold, or varies greatly, or the area varies greatly, you want to make sure that you take these precautions here. If you have pressure, notice there's pressure changes. There could be plugging downstream, so check for that. Maybe install a back pressure regulator to just keep an eye on that so you can see that. If you notice you have fluid loss, you want to do a leak check on one position to see if there's an issue with the seal. You might have to replace the seal. Check a couple other places. If you notice you have that, try changing the cylinder out, and then do a re-leak check to make sure everything else is considered. Another symptom is potential poor refill rates. So it's not refilling at the right rate or speed. You might not have enough fluid. Maybe you need a larger reservoir to draw from. Or if you have high viscosity or low vapor pressure, like we show here. Try using, as I said earlier, larger ports input, either to move up to a 3/8 to see if that'll help so the fluid gets in there a little more freely. And last comment here is we have, there's the controller. If you're using controller, it'll tell you if there's a poor fill alarm, and you can just if you need to change the dead volume rate that's in there, you can actually make the changes from on the controller itself. So we have some things built in to give you a warning that things aren't filling correctly. Okay. And it goes up and down, look at that. So just as a kind of a closure point here, we have a lot of information on our website under our application notes and technical bulletins. These are just some of them here. Tremendous amount of information, either from customers that have used these products or have ran into these issues, but you can also go and look, and if you're curious about, the temperature control jacket, what it can do, how it helps, low flow operation, high temperature, high accuracy, and diagnostics. There's a troubleshooting sheet on there, so there's a lot of things to go for. These are all technical bulletins, but when you look on there, there's application notes on how to use a mixer, pumping CO2, all of that stuff. Tremendous amount of information. Please feel free to go to our website, go to the pumps tab, look under and look for application notes or technical bulletins, and there's an amazing amount of information. There is new stuff being added all the time. So, and if worst comes to worst, you have a question, you can always reach out and contact us also. Okay. With that, we'll take some questions.
And if you have questions, please feel free to use the chat function or the Q&A function, and then Nick and Dale will answer as they come in.
Give it a minute here. All right, so we do have one question that came in, and the question is basically centered around, when I was talking about space. The question was like, what if we need the big D, because the D series is very big. What if we can't fit it onto a table or something like that? So there are other ways to mount the D series. You can be flexible. You can optimize the space that you're using. If you're using a controller, you can put a controller into another spot. With it, we have extendable cords like 10 feet and up to 50 feet that allow you to run the controller from another room if you really wanted to. Or oddly enough, there is something else you can do. You can actually mount the pump a different way. So you can lay it on its side. You could actually mount it upside down if you needed to. There's many different ways. It does not affect the performance or the actual usage of the pump. Okay, that's that one. Do we have any other questions out there from the field at all? So there is actually another question here. We, with our Reaxis reciprocating pump line, the question is, can it do constant pressure? And I say, yes, it can. Our Reaxis pump can do constant pressure, so it's not just for liquids. You can use it to provide pressure when you need it. And actually, the D series can actually can pump gases too to help maybe even create pressure there. So we do have a few options if you're looking for just that within your application. I don't think anybody got anything else. If not, I think we're good there, Tori.
Okay. Well, thank you to Nick for walking through this presentation today. Again, if you have any questions or comments come up after we finish the webinar today, feel free to reach out to us, and we will be sure to take care of that as soon as possible. This webinar is being recorded and will be shared with all registrants and attendees later on this week, so be on the lookout for that email to come your way. Thank you so much to everyone for joining us today, and have a great day.